Okay, so we were talking about this particular f of z equal to 1 upon z square times 1 minus z. So as we discussed earlier, the points z equal to 0 and z equal to 1 are actually risky for us. There the function fails to be analytic, and that is why we exclude z equal to 0 and all points z for which mod z is 1 we are excluding. So let us see how to expand. As far as 1 by z square is concerned, the expansion is quite easy. 1 upon 1 minus z can be expanded as summation z raised to n, and to that you multiply by 1 by z square. So this is the expansion, and here you can very clear cut see there are two negative powers of z, and remaining all, I mean infinitely many, they are positive powers of z. This is in our first unit disk, excluding 0, punctured at 0. Now second expansion we are saying that will take place in the outer region of the disk, exterior region of the disk. So 1 less than mod z less than infinity. What this means, 1 by z will have modulus less than 1. So we can expand 1 upon 1 minus z as per our rule. Up till now we were talking about 1 upon 1 minus omega, and that was summation omega raised to n. Same thing will happen here. 1 upon 1 minus 1 by z will be summation of 1 by z raised to n. Are you following me?
Yes, ma'am.
So now this function can be written as what? 1 upon z square times 1 minus z can be written as, I'll take z common. So this will be z cube. This will be 1 by z minus 1. So minus n also is to be taken out. So what it gives me is 1 minus 1 by z. The expansion of 1 upon 1 minus z is with us here, that we have written, and multiplied outside by minus 1 by z cube. Now this minus 1 by z cube times this expansion gives you minus 1 by z cube minus 1 by z raised to 4 minus 1 by z raised to 5 likewise. So throughout you find minus n is common. Let us take it out. And now how to sum it up? It actually increases by 1 power. So you can write it as 1 upon z raised to n, and you can start your n counting from 3 onwards. This is the expansion. So two expansions we have seen. Here all powers are negative, whereas here you are having only two powers negative and the rest are all positive. Fine?
Yes, ma'am.
Okay. So this was all about the exercises we have solved, seeing the question papers. Okay. Now here let us have just a overlook. If I talk about e raised to z, I find all are positive powers of z, and my what you can say domain is the whole complex plane. We are not excluding 0. But once it goes to 1 by z kind of thing, I apply exponential on 1 by z. At that time I have to exclude 0. And for that I have to talk about the annulus, the whole complex plane except the origin. And there it takes this form. So you are watching all the powers are negative powers of z, and this is z raised to 0. Fine?
Yes, ma'am.
Now here let us see. No positive powers of z appear here. The coefficients of the positive powers being 0. The coefficient of 1 by z is unity. You can check it. Just a minute, I might have lost it. Wait a minute. Yeah. So what happens is the coefficient of 1 by z I'm interested in, and the coefficient of 1 by z is 1 that you are watching. That particular coefficient up till now we have denoted by b1, because what is the Laurent series expansion? You know, a naught plus a1 times z minus z naught. Wait a minute. This is a1 times z minus z naught plus the next you call as a2
A2
positive
times
powers,
z
yes,
minus
z
z
minus z
brackets.
naught bracket square and so on. And to this side, what do you have? This is b1 upon z minus z naught, isn't it?
Yes.
Plus b2 upon z minus z naught bracket square plus and so on to this side. So this particular b1 we are talking of. Coefficient of 1 by z is unity, and coefficient of 1 by z meaning b1. Z square if I say, it becomes b2. If I talk about 1 by z cube, it will be b3 and so on. So we are talking about b1. Now how this b1 will be there? It will be 1 upon 2 pi I times integration over contour f of z dz. Are you getting me? This already
Yes, ma'am.
we have seen. This is the thing. And what happens? What is the integration of this particular? So they are saying b1 is 1. So integration will be 2 pi I. Reverse way we are going.
Hmm.
Knowing b1, knowing this expansion, we are finding out the integration. Got it?
Yes, ma'am.
So this way you have to solve the things. Let us move to this example. Function is f of z equal to 1 upon z minus I bracket square. Where will be the problem? When denominator becomes 0, we have a problem. Where the denominator will be 0?
I वरती.
Yes, at z equal to I. Meaning, whenever the modulus of z minus I becomes 0, I have problem. Are you getting my point? That is why we want the,
Yes, ma'am.
yes, we want modulus not to be equal to 0. So we say 0 less than mod of z minus I. Elsewhere I don't have any problem. So I move up to infinity. So up to infinity. Now this expansion, how it will take place? So we know it will be something of this kind. And now you watch. We are saying from minus infinity to plus infinity. If there are only two negative powers, rest all coefficients will be 0. If there is single negative power, rest all will be zeros. Similarly. So what they are saying, where c suffix minus 2 is 1 and all other coefficients are zeros, because here itself it is given 1 by z minus I bracket square is given. So what will be the expansion? It is itself 1 upon z minus I bracket square. So how this will be? Rest all terms 0 plus 1 upon z minus I bracket square plus 0 plus 0 plus 0 and so on. Positive powers they have coefficient 0. All other negative powers they have coefficient 0. Only this particular will have coefficient 1. Which coefficient is this? This is B2. है ना? Z minus I bracket square. So it will be called as B2. So that is why they are saying this B2 will be 1. Now instead of calling B2, you call it as C suffix minus 2. कारण का आपण एकाच याच्यामध्ये त्याला एका सिंगल समेशन मध्ये घेतलाय n इक्वल टू मायनस इन्फिनिटी पासून ते प्लस इन्फिनिटी पर्यंत आणि इथे आपण म्हणतो Cn म्हणजे C0 काय येईल आपला C0 त्याच्यानंतर ओके याच्या शेजारी आपण लिहूया z मायनस z नॉट ब्रॅकेट रेस टू n. आता क्लिअर होईल ते. C0 म्हटलं तर हा ब्रॅकेट रेस टू 0 सो 1 झाला म्हणजे कॉन्स्टंट टर्म. C मायनस 1 म्हटलं तर 1 अपॉन z मायनस z नॉट होईल. n ला -2 घेतला तर अपॉन z मायनस z नॉट ब्रॅकेटचा स्क्वेअर होईल,
स्क्वेअर.
जे इथे आपण लिहिलंय. म्हणजे त्याला आपण काय म्हणत असतो B2.
हो.
मला असं वाटतं तुम्ही सीच्या नादी न लागता आपण त्याला ए आणि बी एस ह्याच्यामध्ये लिहूयात. सो द थिंग्स विल बी मोर क्लिअर है ना. फाइन.
Yes, ma'am.
All right. So these things let us continue in our next lecture. For the time being, let us stop here. So I think let us meet back. I would like to convey